This new smart chip may have helped China in breaking the greatest technological barrier in modern computing without even a single atom of silicon. But before we get into it, make sure to subscribe to our channel for more Chinese technological breakthrough videos. The fall of silicon's throne. Silicon has been the only lifeblood of modern electronics for more than 60 years now. It powers supercomputers, smartphones, space missions, financial markets, the internet, and nearly every digital system on Earth. Silicon was like the uncrowned king of this information age, but we know all empires have their limits. For years, chip makers like TSMC, Intel, and Samsung kept repeating the same looming problem that we're running out of space. Transistors, which are the tiny on-off switches responsible for running every digital system, have been constantly squeezed to fit into impossibly small dimensions. Now they came down to the size of just 3 nanometers. Physics refuses to further obey our rules at this scale because electrons begin slipping through barriers they aren't supposed to cross normally, and the heat also skyrockets where performance hits the ceiling. If the engineers try to shrink the silicon, it becomes unstable, and the engine of global computing has finally reached its physical boundary. This is the reason why the world of semiconductors has been shaken by what has just happened in Beijing. A new material enters the stage. A small team of Chinese physicists quietly created the world's first fully functional high-performance processor inside a research facility at Peking University. This processor is made of only 2 materials that almost no one took seriously for computing. The first one is bismuth-oxychalcogenide, and the second is graphene. It didn't include anything that the modern semiconductor world was built upon, not silicon or gallium nitride. The researchers didn't just make a working transistor. That alone would be groundbreaking. But they also built a processor capable of outperforming some of the most advanced 3-nanometer silicon chips available today. This silicon-free device runs up to 40% faster than top-tier processors from Intel while also consuming 10% less power. They've done this without relying on the silicon supply chain that the world has spent decades of time in optimizing to perfection. If this technology scales up to a massive level, it could render the global silicon industry irrelevant almost overnight. This is the question that has been haunting every competitor since its successful test was conducted. The miracle of bismuth. What makes this new chip extraordinary is not just that it uses bismuth, but it's actually what bismuth can allow engineers to do that silicon cannot. While silicon can only manipulate electrons with electrical charge alone, on the other hand, bismuth-oxychalcogenide unlocks the ability to manipulate charge and quantum spin at the same time. In other words, think of silicon as a car with only one steering wheel, while bismuth is the same car, except now you can also directly control gravity, friction, and suspension at the atomic level. It will unlock new dimensions of control that silicon simply can never access, and this is possible due to a property known as strong spin-orbit coupling. This property is considered the holy grail of next-generation electronics because it allows electrons to move in predictable patterns even at impossibly tiny scales where silicon fails. And where silicon collapses, the bismuth becomes more stable. Gate-all-around, the new transistor revolution. The Chinese research team didn't merely adopt a new material, but they also redesigned the transistor itself because their devices now use a gate-all-around field transistor, also known as GAAFET. But there is a twist in it as well. GAAFETs made of silicon only pinch the channel from a few directions, while the bismuth GAAFET literally wraps around the channel in 360 degrees, which allows it almost perfect control over the electron flow. Imagine it like gripping a hose with your entire fist instead of just using 2 fingers. That's how precisely this transistor can control the current. This structure becomes more powerful when it's combined with the bismuth spin properties. The results are quite shocking because the operating frequencies of over 3.5 GHz are already demonstrated. Theoretical ceilings approach 500 GHz, while sub-threshold swing of millivolts per decade has been achieved with the transistor size of just 0.5 nanometers thick, which is even smaller than a single silicon atom. All these numbers are not marketing claims, but they are actually from peer-reviewed data from working prototypes. If silicon transistors are bicycles, you can consider these new materials, advanced transistors, the Starships. The graphene interconnect revolution. Now let's talk about the final secret ingredient, which is graphene. It is a single layer of carbon atoms that is arranged in a perfect honeycomb pattern, and graphene can act as the wiring inside the chip. It is considered the most perfect wire ever discovered so far because it has virtually zero electrical resistance, along with tensile strength that makes it stronger than steel, and it also has extreme thermal stability paired with perfect atomic uniformity. Graphene has the potential to connect everything with almost zero loss of signal, while silicon chips require intricate metal interconnects that generate heat and resistance. When graphene is combined with bismuth, the system behaves like an entirely new class of computing engine. It becomes part electronic, part quantum, and part photonic. Why China made this move now? Now, if you are wondering why China has made such a big invention now, then the answer is that China's advantage is not just in engineering, but it's also in geology. China controls 70% of the world's bismuth reserves and 80% of the world's graphene production, along with 95% of global rare earth refining. While the West dominates in silicon only, China dominates everything else that is needed for a post-silicon world. When the US started restricting exports of advanced chips and equipment in 2022, many analysts thought that China would fall behind in development for decades. But inside China, the reaction was totally different. It triggered the largest scientific mobilization in modern history, where a 1.44 trillion yuan semiconductor independence campaign was started. They recruited over 140,000 engineers into a crash program dedicated to reinventing the chip industry from scratch. Actually, China was not trying to catch up to the West, but instead they were focused on building an entirely new road. If you're enjoying this breakdown so far, don't forget to subscribe to our channel for more tech invention deep dive videos. China's Manhattan Project of Microchips. All the laboratories in China across Beijing, Shenzhen, Hefei, and Shanghai were transformed into high-pressure R&D hubs behind closed doors without letting the world know about it. These were not small research efforts, but in reality, they were vast industrial state programs which were designed to bypass Western bottlenecks completely. At the core of this effort, there was only one question. If the US controls silicon, why not use something better? And that's how the race towards post-silicon materials began. The bismuth chip is simply the first thing from these efforts to break into global headlines, but we are pretty sure that it will not be the last, and there is still more to come. Industry panic in Taiwan, Korea, and the US. Within a few days of this research announcement, emergency evaluations started across the entire global tech sector. TSMC quietly initiated a joint research with MIT into finding an alternative material beyond silicon. Intel engineers admitted that this breakthrough is deeply concerning, while Samsung also began drafting internal memos for reassessing its roadmap. Now, if you ask why? So, the answer is, if China can mass-produce silicon-free chips, then the export controls will lose their power, global chip dependency will be totally reorganized overnight, and Western semiconductor superiority will collapse, while China will become the unavoidable technology supplier of the next whole era. This is not just a scientific breakthrough, but it is actually a geopolitical earthquake for all the competitors. The giant problem: mass manufacturing. Now, the only thing that is standing between China and a new semiconductor empire is the hardest challenge of all to overcome. It is how you produce a chip at a mass level that is made of a material which the world has never fabricated at this scale. The silicon ecosystem itself took 50 years to build, and entire cities exist because silicon exists. To replace this empire, China would need new fabrication methods, new deposition chambers, new etching techniques, new lithography wavelengths, and new supply chains, along with new precision tools while developing new AI-driven yield optimization systems. In short, every step of silicon manufacturing must be reinvented for this new material smart chip to be produced at a mass level. It's the technological equivalent of switching gasoline engines with fusion reactors, and that too overnight. This problem is the reason why no Western company has so far attempted such a radical transition, because it is too expensive, too risky, and too disruptive. But China has decided to do it because China had no other choice. A preview of what this chip could enable. Now, if China manages to overcome this giant problem and finds a way to scale this chip into commercial production, the implications will stretch from real-time satellite image processing to hypersonic missile guidance with autonomous drone swarms. In the field of AI, this chip will bring near-zero latency interference, 90% lower compute power, and training cycles will become 10 to 50% faster. And in the consumer tech area, this chip could enable phones to have 3 days of battery life, ultra-thin laptops with supercomputer-like performance, and also seamless AR glasses powered by efficient AI chips. The computing world would unlock an entirely new age of scientific advancement in the post-silicon era, and China may have just taken the first step towards it. The last piece, a unified tech rise. This bismuth-graphene chip is not the only miracle from China, but it's actually one chapter in a much larger wave of technological breakthroughs that have arrived almost simultaneously. To understand the full picture, you have to see the other two milestones as well. Meteor 1, optical chip, processing with light. China has also endangered the empire of NVIDIA by developing the world's first highly parallel photonic AI chip that delivers 2,560 TOPS. This number will double the performance as compared to NVIDIA's most advanced GPUs, while it also consumes less power, which will end up giving another advantage to China in the energy economics. This chip bypasses the entire silicon problem because it uses photons instead of electrons. This innovation is another big step forward by China. Huawei's Pura 80 Ultra National Consumer Shockwave. Another technological breakthrough of the Chinese line in the rivalry against the iPhone, because this Huawei Smart is quite advanced. It has a dual periscope telephoto camera system along with its homegrown Kirin chipset for faster and better processing that Chinese customers really liked. It became the symbol of China's complete technological resilience, even under sanctions. These innovations, from optical computing, camera physics, non-silicon processors, to homegrown operating systems in mobile phones, everything point in the same direction. It has become clear that China is no longer following the global technology roadmap, but instead it is focusing on writing its own. China's smart silicon-free chip is not just a breakthrough, but it's actually the beginning of a new technological era where the entire world now has to race to catch up with China. If you enjoyed this video, do subscribe to our channel for more tech innovation deep dive videos.